So, let's go. Number 1. The Campanian Ignimbrite, Super-Eruption. On a ridge above the Bay of Naples, a small band of Neanderthals stands very still, watching the southern sky turn the color of wet ash. There is no fire on the horizon yet, only a rising gray wall that swallows the daylight, and then the first flakes begin to fall on their shoulders like a cold and silent snow. What they are watching is the largest volcanic eruption the Mediterranean has seen in 200,000 years. It is happening about 39,850 years ago, and it will help close the final chapter on their entire species. The source is the Campi Flegrei, the Phlegraean Fields, a restless volcanic system just west of modern Naples. The date comes from careful argon dating led by the geologist Biagio Giaccio and his colleagues, who pinned the blast to that narrow window near the end of the last ice age. This was a super-colossal event, rated at a volcanic explosivity index of 7. The volcano threw out somewhere around 250 to 300 cubic kilometers of magma, and older estimates of the total ash push toward 500 cubic kilometers. The ash did not stay local. It settled into a distinctive layer that geologists call the Y5 tephra, and they have traced it more than 2,000 kilometers away, all the way to the Russian plain and the early human site of Kostenki on the River Don. Because that single ash layer fell across so much of the eastern Mediterranean and eastern Europe in one moment, scientists now use it as a shared time marker, a line drawn across the whole continent that lets them ask what came before the eruption and what came after. The eruption poured out enormous quantities of sulfur. Climate modelers, including work by the researcher Benjamin Black, estimated that the sulfate haze was heavy enough to drive a volcanic winter, a sudden multi-year chill. And here the timing turns sinister. The eruption struck during an already brutal cold phase, overlapping a period known as Heinrich Event 4, and a frigid stretch of the Greenland record. Europe was cold, and the volcano made it colder, dropping temperatures by several degrees across the region in the years that followed. The blast also injected fluorine and other poisons into the air, and downwind that toxic fallout would have contaminated water and coated vegetation across a vast area, killing food at the source long after the ash stopped falling. The researcher John Lowe used the same Y5 ash as a common horizon to test a crucial question: whether human populations changed before or after the eruption. The event has even earned a grim nickname among some scientists: the eruption that helped clear the stage for modern humans in Europe. The caldera it left behind is roughly 13 kilometers across, and much of it now lies beneath the city of Naples and the Bay of Pozzuoli. A later large eruption from the same system, the Neapolitan Yellow Tuff about 15,000 years ago, showed the volcano was far from finished. At many archaeological sites, the Campanian ash sits like a page break. Below it lie the stone tools of the Neanderthals. Above it appear the tools of anatomically modern humans. For a long time, some researchers read that layering as a murder weapon caught in the act, the eruption that wiped the Neanderthals from Europe. The mainstream view today is more careful. Neanderthal populations were already thinning across the continent, and a widely cited study by Black and colleagues in 2015 argued that the climate shock, though real, was probably not by itself enough to end them. A minority still see it as something close to a knockout blow. All three readings agree on the horror of the moment, a species standing in the ashfall of the biggest eruption in their world. The stakes here are as high as they get. Within this same window, an entire kind of human vanished from Europe. Whether the volcano struck the final blow or merely hurried an ending already underway, it shows how fast a lineage that lasted hundreds of thousands of years can slip below the surface for good. And the system that did it is not dead. Campi Flegrei is still active today. The ground around the town of Pozzuoli rises and falls in slow-breathing swells that scientists call bradyseism, and hundreds of thousands of people now live directly inside the old caldera. If a disaster this enormous can be almost forgotten, it is worth asking how. Number 2. The Cerro Blanco Eruption. 4,500 meters up, on a cold and almost empty plateau in northwestern Argentina, the ground splits and a pale column of ash climbs into a thin blue sky. There are no cities here, no scribes, only scattered herders and their animals, and a wind that carries beige dust across the salt flats until the pastures disappear beneath it. This is one of the largest volcanic eruptions of the entire Holocene, the whole span of human civilization, and almost no one has ever heard its name. Cerro Blanco is a volcanic caldera complex in the southern Puna of Catamarca province. Its greatest recent eruption happened roughly 4,200 years ago, around the 23rd century before the Common Era. It rates a volcanic explosivity index of about 7, and estimates put the erupted tephra at more than 100 cubic kilometers, with a caldera collapse several kilometers wide left behind in that high desert. Research led by the scientist José Luis Fernández Turiel and his colleagues mapped the ashfall and pushed the estimated size of the event upward, and they found the tephra scattered hundreds of kilometers across northwestern Argentina, buried in sediment cores and archaeological sequences alike. That wide ash sheet now serves geologists as a dating tool, a marker layer they can use to fix the age of sites across the region. The deposits are so large that scientists are still remapping and remeasuring them in the 2010s and 2020s, steadily rewriting the tally of the biggest eruptions of the Holocene, a list that used to center on Mazama, Kikai, and Tambora. The eruption sits at roughly 4,200 to 4,700 meters above sea level, a crushing altitude for anything living. For the people of the Puna, who depended on fragile high country pastures and on herds of llama and vicuña, buried grassland and poisoned water meant the loss of the animals that were the center of their whole way of life. The eruption also predates the famous civilizations of the Andes, but it overlapped with the region's early complex societies, striking them without leaving a name. So why has history forgotten a blast this large? The answer is simple and a little chilling. It happened in one of the emptiest places on Earth, a remote high-altitude desert far from any people who could write it down or even carry the memory forward. The eruption produced no eyewitness account because there was, in effect, no witness to leave one. The timing places it near the global 4.2 kilo-year event, a span of widespread drying that stressed societies from Mesopotamia to the Indus. Some researchers have asked whether the aerosols from Cerro Blanco added to the climate stress across the central Andes at that time. The mainstream reading holds that the eruption, while gigantic, had mostly regional climate effects. Others suspect it contributed to Andean hardship. A more speculative camp ties it into the worldwide collapses of the 4.2 kilo-year event itself. Here's the stakes kicker. Cerro Blanco was larger than the 1991 eruption of Mount Pinatubo, a disaster the whole modern world watched on television, and yet it left essentially no trace in the human story. That absence is its own kind of warning about how much of the past can simply be erased. And the volcano has not gone quiet. Satellite radar has detected ongoing subsidence and geothermal unrest, the signs of a hazardous system slowly stirring again. Our next disaster shows that some eruptions do not even need dry land to destroy a people. They can cross the open sea. Number 3. The Kikai-Akahoya Eruption. On a beach in southern Kyushu, a clay pot sits abandoned in the sand, still half full, beside a canoe pulled up above the tide line. Out across the water, where the sea meets the sky, a gray cloud is not drifting, but racing, low and fast, straight toward the shore. What is coming is a pyroclastic flow, a ground-hugging avalanche of superheated ash and gas, and it is doing something almost unthinkable. It is crossing open ocean to reach the people of Japan. The source is the Kikai caldera, a volcanic crater that sits mostly submerged in the sea south of Kyushu. Its major Holocene eruption, called the Akahoya Eruption, happened about 7,300 years ago, around the 53rd century before the Common Era. It ranks among the largest eruptions of the Holocene, a volcanic explosivity index of about 7, throwing out more than 150 cubic kilometers of material. Its ash, known as the Kikai-Akahoya tephra, blanketed much of the Japanese archipelago and is now a cornerstone marker layer for dating the region's prehistory. Before the eruption, the early Jomon people of southern Kyushu were flourishing. They were skilled potters and foragers, makers of some of the oldest pottery on Earth, one of the most sophisticated hunter-gatherer cultures the ancient world ever produced. Then the volcano erupted, and the archaeological record of southern Kyushu goes dark. For something on the order of 900 to 1,000 years, the region was effectively abandoned. A whole cultural world was erased from a landscape that had supported it for generations, and the ash-choked soils and ruined food resources explain why no one could return for so long. When people finally did drift back, the culture that had lived there was gone, its knowledge and its way of life scattered into silence. The eruption did not kill by ash alone. The blast threw up tsunamis that would have battered the surrounding coasts, adding drowning to burning and burial. It is sometimes called Japan's single greatest natural catastrophe of the Holocene, and because it happened thousands of years before writing reached the islands, it survives only in geology and archaeology, never in a written word. The threat has not passed into history. Between 2018 and 2021, a survey led by the volcanologist Yoshiyuki Tatsumi of Kobe University identified a giant lava dome inside the Kikai caldera, evidence that a large body of magma is still there, still charged. The caldera itself is roughly 19 by 17 kilometers across, and because it lies beneath the sea, it is one of the least visible and most dangerous volcanic systems on the planet. That undersea setting also means it is only lightly monitored, a giant we can barely watch. Geologists lean on its ash the way North Americans lean on the ash of Mount Mazama as a fixed line for dating the deep past. How exactly the eruption emptied southern Kyushu is debated. The mainstream view combines several killers at once: the pyroclastic flows, tsunamis thrown up by the blast, and ashfall that poisoned soil and water and destroyed the food supply. Others emphasize the collapse of the wider food web in the years afterward. A darker reading simply calls it what it looks like: a total extinction of a culture. The stakes are hard to overstate. A refined, settled people vanished for a millennium because the land itself became impossible to live on. Modern models suggest that a comparable eruption from Kikai in the future could threaten millions. Our next disaster was so large it may have been seen from the far side of the world, and yet at its source there was no one there at all. Number 4. The Hatepe Eruption of Taupō. The sky over the center of New Zealand's North Island has turned the deep and impossible red of a wound, glowing above an eruption that no human eye is there to see. There are no people on these islands yet. But thousands of kilometers away, on the other side of the planet, a Roman writer looks up at a strangely reddened sky and notes it down. And in China, another chronicler records the same crimson daylight in the same year. They are describing, without knowing it, the far-off breath of one of the most violent eruptions of the last 5,000 years. The volcano is Taupō, now hidden beneath the lake of the same name in the middle of the North Island. Its most recent major eruption, often called the Hatepe Eruption, has been dated to about the year 232 of the Common Era, fixed by precise radiocarbon wiggle matchwork led by the volcanologist Colin Wilson and others. It rates a volcanic explosivity index of about 7 and erupted roughly 120 cubic kilometers of material in a short, savage burst. The climactic phase produced the Taupō Ignimbrite, a pyroclastic flow that swept outward at hurricane speed and flattened forests across the central North Island, overrunning hills more than 80 kilometers from the vent. The eruption column is estimated to have punched more than 50 kilometers up into the stratosphere, among the tallest eruption plumes ever inferred anywhere on Earth. Those flattened, buried tree stumps are how scientists later dated and reconstructed the blast so precisely, and its ash and pumice now turn up across much of the North Island and in marine cores far offshore. The 232 figure itself is a revision, replacing an older estimate that had placed the eruption closer to the year 180. And here is the strangeness at the heart of it. New Zealand had no human population in the year 232. The Maori would not arrive until roughly the 13th century, more than 1,000 years later. So the single most explosive eruption of its age, per unit of magma, tore open an empty land, and its only living witnesses were people on the opposite side of the globe who saw the sky change color. Those far-field records are the subject of real debate. The account of the Roman historian Herodian, describing a strangely disturbed sky, is one of the texts most often cited alongside the Chinese chronicles of red daylight. The mainstream reading holds that a stratospheric veil of volcanic aerosols from Taupō could indeed have reddened skies and dimmed daylight in Rome and China, a genuine global fingerprint. A more cautious camp warns that red skies have many causes, and the match may be partly coincidence. And in the ancient world, of course, such skies were read as omens and portents, not eruptions. Whatever the truth, the eruption ranks with the largest of the entire Common Era, comparable in raw explosive character to the far more famous eruption of Tambora in 1815, which chilled the whole planet and gave the world a year without a summer. The stakes here are a kind of eerie paradox. A catastrophe enormous enough to color the skies over two empires left no story at all where it actually happened. Taupō is classified today as an active supervolcano, watched closely by the agency GNS Science. Our next disaster hides in an even gentler disguise, beneath a quiet lake in the heart of Europe. Number 5. The Laacher See Eruption. In a forested river valley in what is now western Germany, a group of Ice Age hunters drops everything and runs as ash begins to sift down through the pines and settle on the backs of fleeing reindeer. The air smells of sulfur. The stream they camped beside is turning gray. They belong to a late Paleolithic culture that archaeologists call the Federmesser, and they are living through the largest volcanic eruption Central Europe has known since the blast that fell on the Neanderthals tens of thousands of years before. The eruption formed the Laacher See, a crater lake in the Eifel region near the Rhine. High-precision dating, including a study led by the researcher Frederick Reinig in 2021, placed it at about 12,880 years ago. The ash it produced, the Laacher See tephra, is one of the single most important marker layers in the study of late glacial Europe. It rates a volcanic explosivity index of about 6, and its ash spread from northern Italy in the south to southern Sweden in the north, a fan of gray across much of the continent. The eruption did more than rain ash. It dammed the river Rhine with its own deposits, and when that natural dam later failed, it released a catastrophic flood down the valley, a second disaster born from the first. Its plume darkened skies and brought short-term regional cooling, and the ash-sealed late glacial hunting camps beneath it, preserving a snapshot of that vanished world. That same buried ash layer now gives archaeologists and pollen scientists a precise timeline to line up records all across the continent. Thousands of years later, humans would return to mine the eruption's pumice, quarrying it in Roman and medieval times to grind grain into flour. Now, the record turns genuinely contested. The eruption landed remarkably close in time to the onset of the Younger Dryas, a sudden and severe return to near-glacial cold that gripped the northern hemisphere for more than 1,000 years. For a long time, that looked like a coincidence too neat to ignore, and the 2021 redating reopened the argument with fresh force. But most researchers hold that the Younger Dryas was driven by changes in ocean circulation, not by a single European eruption. A minority still argue the volcano could have helped trigger or nudge the cooling. And at the fringe, the timing gets swept into wider impact catastrophe theories about the same period. The stakes give this one a strange beauty. This was Europe's most significant eruption in tens of thousands of years, larger than anything the continent has seen since the blast that fell on the Neanderthals. And today, its crater is a tranquil lake dotted with sailboats and lined with tourists who mostly have no idea what they are floating on. Yet the lake is still exhaling carbon dioxide up through its bed, a phenomenon the locals call moffetts, proof of living magma beneath. The East Eifel volcanic field is not extinct, and deep low-frequency earthquakes suggest magma is still moving down below. Our next disaster is the strangest of all, because it involved no eruption whatsoever. It was the slow death of a green and living world. Number 6. The Green Sahara Collapse. On a rock wall deep in the Algerian desert, someone painted cattle and swimmers and long-horned herds moving toward water, in a place where today there is nothing but sand to every horizon. The paintings are not fantasy. They are portraits of a world that really existed, a green Sahara full of lakes and rivers and grazing animals, and its disappearance is one of the largest disasters in human prehistory, even though it left no single burning day to remember it by. For much of the early and middle Holocene, roughly 11,000 to 5,000 years ago, North Africa lived through what scientists call the African humid period. The Sahara was a semi-humid landscape of lakes, rivers, and grassland, home to hippos, crocodiles, elephants, and fish. Rock art at sites like Tassili Najer records cattle herders and a well-watered life. At its peak, a vast body of water, known as Mega Lake Chad, covered an area larger than the modern Caspian Sea, on the order of 300,000 square kilometers or more. The greening had an astronomical cause. Slow wobbles in Earth's orbit, a cycle called precession, strengthened the West African monsoon and dragged the rains far to the north. Then, beginning around 5,500 years ago, that engine reversed. The monsoon retreated, and the region dried in an episode often called the 5.9 kiloyear event. The scientist Peter Domenical and his colleagues read the collapse in cores of ocean sediment off the West African coast, where wind-blown dust suddenly surged. One core in particular, off Mauritania, recorded a sharp jump in desert dust that marks the death of the Green Sahara. How fast it happened is still argued. Some archives suggest an abrupt flip over just a few centuries. Others read a more gradual drying spread across 1,000 or 2,000 years. Part of the disagreement is real physics, because a feedback loop between vanishing plants and a brightening, more reflective land surface likely amplified and accelerated the drying once it began. Lake sediments preserve the whole story in places like Lake Yoa in Chad, where an unbroken record captures the slow-motion turn from water to sand. As the lakes shrank and the rivers failed, the cattle pastoralism that had defined the Sahara for thousands of years simply collapsed, and the settlement map of an entire subcontinent was rewritten for good. The human consequences were immense. As the water vanished, people abandoned the Sahara and pushed toward the one reliable river left to them, the Nile. Many archaeologists connect that crowding of people along the Nile Valley to the rise of ancient Egyptian civilization itself, a great culture born partly from a great catastrophe. It is a haunting thought that one of humanity's most celebrated civilizations may owe its existence to refugees fleeing a dying grassland. The desertification rarely appears on any list of great disasters, precisely because it had no single flash of violence, no burning city, no day of doom, only a slow closing of the world that emptied it all the same. The stakes are almost too large to feel. A habitable subcontinent turned into the largest hot desert on Earth, about 9 million square kilometers of sand, within a span comparable to recorded history. And the cycle is not finished. in roughly 15,000 years, the orbital rhythm will swing back, and the Sahara will bloom again. Our next disaster took the opposite form. Not a world drying out, but a world drowning and freezing at once. Number 7. The Lake Agassiz outburst and the 8.2 kiloyear cooling. An ice dam the size of a mountain range groans, cracks, and gives way, and a wall of turquoise meltwater bursts through the gap and roars out across a frozen North American plain toward the sea, dragging house-sized blocks of ice in the torrent. This is about 8,200 years ago, and what is emptying is not a lake in any ordinary sense. It is a body of fresh water larger than all of the modern Great Lakes combined. Lake Agassiz was an enormous proglacial lake, fed by meltwater pouring off the retreating Laurentide ice sheet at the end of the last ice age. At its greatest, it covered parts of Manitoba, Ontario, Saskatchewan, Minnesota, and North Dakota. Around 8,200 years ago, the wall of ice holding it back, together with the neighboring Lake Ojibwe, failed catastrophically. The outburst released an estimated 100,000 cubic kilometers of freshwater or more into Hudson Bay and the North Atlantic in a geological instant. The scale is almost impossible to picture. A continent's worth of meltwater emptied in perhaps a few months to a couple of years. A single flood large enough to reorder the ocean. Its dried lake bed is still with us today, most famously as the flat and fertile Red River Valley of Manitoba, a breadbasket left behind by a catastrophe. That flood of fresh water did something far larger than any local damage. It is thought to have disrupted the Atlantic overturning circulation, the great conveyor of warm and cold water that moves heat around the ocean. The mechanism was proposed and developed by researchers including the oceanographer Wallace Broecker, and the drainage most likely ran out through the Hudson Strait. When the conveyor faltered, the climate lurched. This is the 8.2 kiloyear event, an abrupt cooling recorded with startling sharpness in Greenland ice cores, a drop of several degrees that lasted on the order of 150 years. The cooling reached far beyond the ice. It brought drier, colder conditions across the North Atlantic region, into Europe, Africa, and Asia, shortening growing seasons and stressing early farmers and foragers alike. The sudden drainage also raised global sea level in a rapid step, somewhere around half a meter to more than a meter, enough to drown low-lying coastal settlements and finish off shrinking land bridges. Some researchers connect the event to disruptions among early farming communities in the Near East and Europe, and to the same drying pulse that helped kill the Green Sahara. It is now one of the best-studied examples of abrupt climate change in the whole geological record, precisely because it happened so fast and so hard. How the lake emptied is refined, but not fully settled. The mainstream picture is a single mega outburst. Some newer work argues for staged drainage in more than one pulse. Either way, the links between this flood and the wider world of early agriculture keep multiplying. The stakes could not be more current. One lake, emptying in perhaps months to a couple of years, chilled half the planet for a century and a half. That is exactly the kind of tipping point climate scientists now watch for as they study the risk of a slowing Atlantic circulation today. Our final disaster is the one that people did not entirely forget, because its witnesses found a way to carry the memory across 7,000 years. Number 8. The Mount Mazama Eruption. On the flanks of a great mountain in what is now southern Oregon, a band of Klamath people flee downslope through falling ash as the summit above them buckles and caves inward on itself. They will survive to tell the story, and their descendants will still be telling it 7,700 years later. The mountain is Mount Mazama, and its collapse is about to create the deepest lake in the United States. The climactic eruption of Mazama, a stratovolcano in the Cascade Range, happened about 7,700 years ago, around the 57th century before the Common Era. It rates a volcanic explosivity index of about 7, one of the largest eruptions in North America of the whole Holocene. The volcano emptied its magma chamber of roughly 50 cubic kilometers of material, and, drained from within, its summit collapsed into the void. That collapse formed the caldera now filled by Crater Lake, which reaches a depth of about 594 meters, making it the deepest lake in the country. The Mazama ash is one of the most useful marker layers in North American science. It fell across roughly 1.7 million square kilometers, blanketing 8 or more modern states and reaching into Canada, and traces of it have even been found in Greenland ice cores. Geologists use it as a golden spike, a fixed line for dating countless archaeological and geological deposits. Beneath that ash at sites like Fort Rock Cave, archaeologists found a pair of sandals woven from sagebrush bark, proof that people were living in this landscape before the mountain fell. And those people remembered. The Klamath preserve a legend of a battle between Lau, the chief of the below world, and Skell, the chief of the above world. In the story, Lau is driven back down into the mountain, which then collapses upon him. It is, in the language of myth, an astonishingly accurate memory of a real geological event nearly 8,000 years old. The mainstream reading treats the eruption as a straightforward volcanic collapse. Anthropologists point to the Klamath story as a remarkable case of deep oral memory, preserving a true event across hundreds of generations. More speculative readings stretch the catastrophe further than the evidence allows. Before the summit fell, the eruption sent devastating pyroclastic flows racing down Mazama's flanks for tens of kilometers, scouring the slopes clean. After the collapse, the volcano was not quite done, and smaller eruptions built a cinder cone that now breaks the lake surface as Wizard Island. The stakes are easy to picture. The Mazama eruption was more than 40 times larger in erupted volume than the 1980 eruption of Mount St. Helens, and people were living directly in the zone where the ash fell. Today, the Cascade Arc is still active, and its volcanoes are monitored closely by the United States Geological Survey. Crater Lake, ringed by caldera walls that rise some 600 meters above the water, has no rivers flowing in or out. It is filled entirely by rain and snow, which is why its water is among the purest and bluest on Earth. A serene monument sitting in the throat of a catastrophe, protected as one of the country's oldest national parks since 1902. Lay these 8 disasters side by side, and a pattern rises out of them. Each one slipped through the cracks of memory for a reason. Some struck where there was no writing to record them, and no dense population to carry the story forward. Some, like Cerro Blanco, erupted in places so remote that there was scarcely a human being to witness them at all. Kikai hid its greatest violence beneath the sea. Taupō tore open a land with no people on it. And the Green Sahara died so slowly, over centuries, that there was never a single dramatic day to mark and mourn. That is what makes a disaster forgettable. Not smallness, but silence, an absence of the witnesses, and the words that turn an event into history. Cerro Blanco was larger than eruptions the modern world watched in horror, yet it fell on empty ground and left no name. The Green Sahara emptied an entire region without ever giving people a single day to fear. What is remarkable is that the Earth kept its own record even when people could not. Layers of volcanic ash sealed in soil and mud, and thin bands of chemistry frozen into ice cores, let modern science remember what no human hand wrote down. A single ash layer, dropped in one moment across a continent, can now be traced from site to site and used to synchronize the story of the entire ancient world. And in the rarest cases, like the Klamath and Mount Mazama, an oral tradition managed to carry the truth across thousands of years. A bridge of memory reaching back nearly 8,000 years, where writing never existed at all. For all that tephra and ice have taught us, these disasters keep their secrets. We still do not know whether the Campanian Ignimbrite truly tipped the Neanderthals into extinction or merely hurried an ending already in motion. And the honest answer is that the evidence points both ways. We do not know for certain whether the Green Sahara died abruptly over a few centuries, or faded gradually over 2,000 years, because different natural archives tell different stories. The timing of the Laacher See Eruption and the onset of the Younger Dryas remains a coincidence that scientists cannot fully explain away or fully connect. We are still arguing over whether Lake Agassiz emptied in a single megaflood or in several staged pulses, and over exactly how far the ripples of the 8.2 kilo-year cooling reached into the lives of the first farmers. Even the true magnitude of Cerro Blanco is a moving number, revised upward as researchers keep remapping an ash sheet no one measured for 4,000 years. And perhaps the most unsettling gap of all is the simplest one. We do not really know what a repeat of Kikai, or of Campiflegre beneath the streets of Naples, would do to the millions of people who now live where those calderas still breathe. The final thread tying these 8 together is the most uncomfortable one. Almost none of these volcanoes are truly dead. Campiflegre is rising and falling under a crowded Italian city. Taupō sits watched and restless beneath its lake. Kikai holds a fresh dome of magma under the sea, and the Eiffel still trembles with the movement of molten rock far below. Even the great climate lurch of the 8.2 kilo-year event has a modern echo, in the tipping point scientists now track as they study the slowing of the Atlantic circulation. These forgotten disasters are not really relics. They are a catalog of what the planet has done before and can do again, written in ash and ice, waiting to be read by anyone willing to look. We remember them now, not because anyone wrote them down at the time, but because the Earth kept the receipts, and because a handful of scientists learned how to read a language older than any book. If the deep past still has questions for you, there is another investigation waiting on your screen right now, and subscribing keeps them coming.